Hello there. In this tutorial, we are going to cover shaders in Godot, which are one of the most powerful concepts in all of game development. To start with a really basic overview, if you're working in the editor, you might have a graphic with a bounding box. So this would be the position. But when you come to the actual game via the shader, you can change the graphic and change the position. Now this example is fairly basic, but if you know what you are doing, you can do some crazy things. For example, you could make a flame, you could make an animated health indicator, you could create a Zelda-style stamina bar, you could create three-dimensional water, you can make objects move in the wind, and there's basically no limit of what you can do. If you understand shaders, you can make your games look significantly better. And in this tutorial, we're going to start with the absolute basics to get into shaders in the first place. To get started, there are some fundamentals that you absolutely have to understand. The first one is going to be, if we try to move a graphic from the editor to the actual game, we are going through what is called a shader pipeline. That one looks like this. We are starting all the way at the top, and then we are going through this entire process through a whole bunch of steps. And throughout this process, we are getting closer and closer to an actual graphic. By the end of it, we have a frame buffer, which contains the graphic we want to display. And during this process, you can customize things. For example, during the fragment shader, you can customize the colors that are being drawn. Although step by step. Before we get to that, the next important thing that you have to understand is that a shader is looking at every single pixel of the graphic individually and then applies an effect. So for example, if we have a graphic with 4 pixels, we are going to run some code for every single pixel at the same time. Or to stick with the example you can see on the left, for this graphic, every single cell in there would be a pixel. And we are running a code snippet for every single one of them. And that we are doing at the same time, which sometimes can be slightly confusing, but it's something you get used to quite fast. And there are 2 types of shaders that we really care about. Number 1 is a vertex shader. This one determines the position of the pixels that we are working with. This happens quite early in the shader pipeline, all the way up there. The other shader is the fragment shader, and this one we already looked at very briefly down here. This one determines the color and the transparency of a pixel. So for example, we could have some pure red pixels or some black ones. Also, we're going to have a whole bunch of transparent pixels. All of that happens via a shader. So that's the basic theory that you have to understand. Next up, there are 2 ways to write shaders in Godot. The first one is you can write a script, and this happens not via GDScript, but via a language called GLSLES 3.0. Sounds like a mouthful, but an example of this that we are going to write in this tutorial would look like this. This kind of coding language is somewhat similar to the C programming language, and people tend to assume that it's really complicated. But in practice, it's really not that bad. So, for example, if you look at the code, all the way at the top, we are creating some global variables. They all have a name, like color or alpha. And after that, we are assigning a value via the equal sign. The only thing that massively changes is that before we are creating a variable, we have to define what kind of data type we want. For example, we could have a vector4 or a float. Also, we will always need a semicolon at the end of every line. Getting used to that, if you have only used GDScript so far, then this can be a bit of a problem. But honestly, after a week of working with shaders, you will just do it automatically. We can also create functions. In there, we need a name for a function. We can determine some parameters. And inside of curly brackets, we can then write some code. The only thing that's massively different is that the first word has to be the return value of the function. In this example, both functions don't return anything, so the return value is void. And that's basically it. The shading language doesn't get that much more complicated than basic GDScript. Or in other words, if you can write GDScript, you can totally write shaders. Just keep an open mind and jump into it. Within a couple of days, you will be totally fine. Now, the alternative to a script is a visual shader. This one would look something like this. These shaders, I find, are quite good to get started with the shading language in general. You are getting a ton of visual feedback, and it's quite easy to move things around. However, as we go along, you probably are going to use less and less of a visual shader and more of a script, simply because the script is significantly more efficient. And to demonstrate what I'm talking about, this entire shader looks quite complex, but in code, we are just doing that. Those two things are pretty much equivalent, which I think illustrates quite well which one is more efficient to write. But in general, I would recommend you to understand scripted and visual shaders. At the very least, it's really good practice, and sometimes you find an example online of a shader, and they might use either a visual or a script shader, so you want to understand both. Also, if you work with other people, sometimes they have a certain kind of preference. That being said, if you understand a scripted shader, you most likely will also understand a visual shader. And that is basically it for the theory. Let's start writing some actual shaders. Alrighty, here we are in Godot, and I already have one scene open. It's a really simple one. We have a parent node 2D along with a sprite 2D. And that's literally it. There's no code or any other logic inside of this project. And what we want to do is to apply a shader to this sprite 2D. For that, we want to go to Material and then assign a new material. There are two options actually, Canvas Item Material and a Shader Material. Shader Material is what you want. After that, you can see a sphere, although other than that, not much happened. Although, what you can do is create a new shader. At the moment, this one is empty. And we want to create a new shader once again. And on this dialog, you do want to be careful. You want to give your shader a name and then save it as .trace. That part's quite easy. But then at the top, we have a type and a mode. For the type, you can either have a shader or a visual shader, or a shader include, but that's not too important right now. These two options are what you actually want to care about. To get started, I am going to create a visual shader, although later on, I am going to create a regular shader as well. The difference between these two, by the way, is that a normal shader simply uses code, whereas a visual shader uses a node system, meaning you are getting a whole bunch of nodes and you are connecting them. You'll see in a second what I mean. Besides that, we have a mode, and in there we can select spatial, canvas item, particles, sky, and fog. If you wanted to create a specific kind of shader for these kind of options, you would select that shader. Canvas item is for 2D graphics, and spatial is for 3D objects. In our case, we want to create a 2D shader, so I'm going to select canvas item. Finally, I want to call this one intro visual. So it's a bit clearer that we are using a visual shader. After that, I want to click on create, and nothing happened. To actually see what's going on, you want to click on the shader you have just created in the inspector. So if I click on that, now we can see something. And let me show the sprite 2D as well. There we go. On the left side, you can see the file that we are currently working in, intro_visual. And then on the right, you have a field where you can place some nodes. And one node we already have, that is called output. Whatever final value we are going to assign to these values, like for example color or alpha, is going to be the final value for each pixel inside of this graphic. Remember once again, when we are working with shaders, we are looking at every individual pixel of the graphic and then assign a custom value to it. For example, we could change the color or the alpha value, whatever we're specifying either in color or in alpha. There are a few more options, but those tend to get a bit more advanced. So for now, I am going to ignore those. Oh, and by the way, there's one more really important field you want to be aware of. If you look at the top of this field, there we have a fragment drop-down menu. There's also vertex and light. If you click on vertex, you get a completely separate menu. And that is what I talked about in the beginning. You have different kinds of shader. A vertex shader is going to work with the position of the pixels, while a fragment shader is going to work with the color. Or rather, the color, the alpha values, the normal values, the light vertex, shadows, and stuff like that. Also, if you click on the light, then we get a few more options, but that's once again a little bit more advanced. For now, I simply want to work in the fragment shader. And I suppose at this point, we should actually make something happen, so it's not getting too boring. Let's start working with the alpha value. That is one of the simplest values you can work with. And if you look on the left of the value, there we have a bluish dot. This dot is important because it's telling you what kind of data type this value wants. If this dot is blue, this value is expecting a floating point value. Whereas for color, we have a pinkish value, which is going to be some kind of vector. So for example, for the color, we always want to have a vector with red, green, and blue. But step by step. First of all, we want to work with the alpha value. And to get some kind of value, we want to create a new node. This you can do by right-clicking somewhere on this field, and then you get a dialog. Alternatively, you can also click on Add Node, and then you get the same dialog. Now, inside of this dialog, you have a ton of nodes that you could be selecting. Although nobody really uses the drop-down menu. Since you have so many nodes, you would rather use the search functionality. It's kind of similar compared to the node tree when you want to add a new node in general to your scene. In our case, we want to create a float. And if I simply type in float, we are getting a whole bunch of options. The one I want to work with is called a float constant. If I now click on create, we have another node. And for that one, if you look on the right of it, you can see we have another blue dot. So what you can now do is connect this dot to the alpha dot. And now we can see that our sprite has disappeared. That is because we are now setting the alpha value of it to 0. But if we are setting this thing to 0.5, then we are getting 50% transparency. And if we set it to 1, we are back to the default. Also, what is really important to understand, and let me hide the shader editor for just a second. Look closely at this Godot logo, because it changed compared to what we had in the original. As a matter of fact, let me also add in another instance of the logo. And there you can see it quite a bit better. The logo on the right is the default logo. There's no shader at all. However, the logo on the left has a shader that sets the alpha value to 1, which means that every single pixel is going to be visible, which you notice with the corners. In the original logo, those have an alpha value of 0, meaning they are hidden. But since we have now set every pixel to be visible, you can see the color. And because of that, these values are now visible. Now, this obviously isn't something that we want to do. And fortunately, there are lots of tools that help you to hide this kind of thing. For example, what we could be doing from the original graphic, we could read which pixel has transparency values and then apply that to our new sprite as well. But that's going to be a bit more advanced. For now, just don't worry about it. Just keep in mind, later on, we can control per pixel what kind of alpha value we want. All right, first of all though, let me bring all of this back into view. There we go. So now we can assign one value to our alpha value. I suppose just to have something, let's set it to 0.8. Also, what you really need to understand is how to connect these different nodes. At the moment, we are simply connecting a float constant to our output node. But this doesn't have to be direct. For example, what we could be doing is add another node. For that, I'm going to right-click on it and then type into the search field multiply. And be careful here, there are loads of options in terms of multiplications. For example, we have multiplied with vector 2, vector 3, and vector 4, and then even more options. In my case, I want to pick multiply with float. If I double-click on that, we now get another node. And for example, what I could be doing is connect the float constant node to this float operation. And then connect this one to the alpha. That way, whatever float constant we have assigned, we are going to multiply that value right now with 0. The final value of that is going to be our alpha value. In this case, it's going to be 0 because whatever number you multiply with 0 is going to become 0. But what we can do as well is create another float constant and set this one to, let's say, 0.5. This I can now drag into the float multiplier, and now we get 0.4 as the final value. Simply because we multiplied 0.8 with 0.5. If I set this value to 2, we are getting an alpha value of 1. So that's a bit more visible. And I hope that system makes sense. It's really important to understand. Basically, when it comes to a shader with nodes, you always add a whole bunch of nodes and then connect them via other nodes. Every single node in the visual shader has a couple of slots, and via them you can either send out data, like we have done here, or receive data, like our float operator. That way you can combine different values very easily. Also, what you can do is click on the icon next to a node, or the value inside of a node. Now, this for a float isn't going to be particularly useful, but I hope you can kind of see what's going on. Basically, for the float, if I set this to 0.9, then, okay, it's still not going to be terribly useful. But if we, for example, had a color in there, and then if we multiply the color with a value, we would see the output. As a matter of fact, let's do just that. And for that, I want to minimize and hide the eye and give myself a bit more space. When you're working with visual shaders, you want to be really careful about organizing all of this. It can get very messy very fast. But all right, let's work on the color. For that, I want to right-click on this field again and create a color. So type color into the search field. This once again gives us a whole bunch of options, and I want to create a color constant. Double-click on that, and now we get another node. On there, we can click on this white field and select a color. I don't know, let's go with a reddish color, something like that. Choose whatever you want, the specific color really does not matter. If you now click outside of it, we have another color. And now, if you click on the eye, this is going to make a whole lot more sense. Also, for this particular node, we have an arrow next to the eye, where we can see the various individual colors. For example, we can get only the red amount, only the green amount, the blue amount, or the alpha amount. For these values, the brighter the value is, the closer we are going to be to a 1. Meaning alpha is pure white because there is no transparency. We always have the full amount of the alpha value. However, for example, for red, we have a little bit less because we don't have the full amount of red, which you can see quite well when you look at the green value. So this color is fairly dark. But in our case, I want to look at the full color. This value we want to assign to the color. And there we get the color value that we have just assigned. This we can also change. Let's say if I wanted to have a bluish color, something like this. Now we get a blue color. And that's literally it to get started. At this point, we can already update the alpha value and the color. For literally any shader that gets more complex, we simply keep on adding more nodes and make them work with each other to create more sophisticated graphics. That's literally it. However, there's one thing I really want you guys to pay attention to. And that is, I hope you have a good eye for color. And let me zoom in. Look at these dots very carefully. Both are pink, but a slightly different shade of pink. The one on the right is a bit more washed out. Especially if you're watching this on YouTube, the colors might be even more washed out. So this might be hard to see. But look at it closely, and I hope you have Godot open on the side as well. The colors for these two slots are different. That means that the slightly more washed out one is a vector 3, where we are expecting a color for red, a color for green, and a color for blue. Whereas the slot on the left is going to be a vector 4, for which we have a red color, a green color, a blue color, and then finally an alpha value. In fact, what you can do is click on this drop-down menu. There you can see the different values. We have red, green, blue, and alpha, all inside of a vector. Now later on, understanding these data types will become even more important. But when you are using visual shaders, Godot is quite forgiving. What is happening at the moment is that Godot is simply picking the first 3 values and then passing them into the vector 3. That way, we can safely pass a vector 4 into a vector 3 and still get a result that you would expect. Now, if you understand that system, and let me hide all of the color stuff, I want to disconnect the color for now and instead create another float constant. What do you think is going to happen if I connect this float value to the color? Well, let's try, and we are getting a grayish color, which is going to be a bit confusing, but we're getting gray because of the alpha value. If I disconnect the alpha value, we have an alpha value of 1. And now we're getting a pure black color, and also, if you pay close attention, the corners of our graphic with the shader are now back to being actual corners. That is because at the moment we are only updating the color. The alpha values, however, are being retained, so the corners stay the same. What happened here? And basically, let me zoom in again. From the float constant node, we are now getting a single float value that is going to be 0, or 0.0 to be specific. Since we are passing that into a vector 3, Godot has to convert that value somehow to make all of that work. And the thing that Godot is going to do is, for the vector, we want to have a red, a green, and a blue color. Godot simply passes the same value into all three of them, which means if I set this value to 0.5, then we should get a grayish color. And if I set it to 1, we're getting pure white, because now red, green, and blue are all 1.0, which is going to be a white color. Once again, it is going to be really important to understand these values that you are passing around. To make that system even more understandable, what we can do, and let me get rid of this float constant, and then we are going to look at the color again. Also, I want to add another node, and that is going to be called a vector for decompose. This is a node that, well, decomposes a vector 4. And for that, you want to first of all get some kind of input vector, which in our case is going to be the color. After that, we get the x, y, z, and w value. Although in our case, I call these values red, green, blue, and alpha. You could use either name, they both work just fine. I hope that makes sense. And once you have that, for example, what you could be doing is use these values kind of randomly. If I, for example, connect the x to the alpha value, now we are getting a very faint image. And that is because we currently have a blue graphic, which has a very low amount of red. You can see it there. As a matter of fact, the way you want to think about it is now we have a red value, a green value, a blue value, and an alpha value. And these values are being decomposed into x, y, z, and w, which means if we increase the amount of red we have and click out of it, we should have much more of an alpha value. And we do, so this is working. Not necessarily something that you would want to do, but also not something that's entirely impossible. So something like this you are going to see reasonably often. However, that's also not what I want to do. Instead, I want to add another node, and that is going to be a vector 3. Or to get the full name, we want to have a vector 3 compose. This one is basically the opposite of a vector decompose, in the sense that we now can specify 3 values, x, y, and z, and the output is going to be a vector. In my case, I want to assign x to x, y to y, and z to z. And then this value I'm going to assign to the color. Now we are getting the color that we are specifying in the color constant node. Also, what you can do at this point is click on the eye, and there you can see a preview of the color. And let me reorganize things a bit so we have more space. Now with this system, we are much more explicit about our data type, meaning we are starting with a vector 4 for our color, we are decomposing the vector 4, and from the values x, y, and z, or RGB, we are creating a vector 3, which we are assigning to the color. Not something we have to do, but to explain how this node system is going to work, I hope this system makes more sense. Also, what you can do in here is mess around with the values. You can simply switch values around, and then you get different kinds of output. If you, for example, want to invert a color, this can be really powerful. Or if you want to convert a color to a grayscale, what you could be doing is assign the same value to all 3 of them, and then you get the color in the grayscale. Alrighty, we are nearly done with the basics. There are just 2 more concepts that I want to cover. Number 1 is you have a couple of keywords, or in this case, specific nodes that are really useful. For example, what you could be adding is time. This is going to give you the time since the project was started, or to be a bit more specific, since the scene was initiated. For example, what we could be doing, and let me rearrange things once again, is we want to connect this input, which at the moment is going to be a floating point value, to our alpha. And now you can see that we, well, get the full amount of alpha values. However, what we can do, and let me minimize the shader editor and get rid of this sprite 2D. We're not going to need it anymore. Instead, I want to move this sprite 2D a bit more into the viewport. So when I run the scene, we can see what's going on. And there we can see, over time, we get a higher alpha value. For this particular instance, that wouldn't be particularly useful, but if you want to have time inside of your shader, this is how you would do it. And there are other similar kind of constants. For example, if you want to have pi, you would simply type in pi, and then somewhere in there, you get pi, or pi divided by 2, or 4. There's also tau, which is pi times 2. All of those are simply constants that you could be working with. Although in my case, I don't really care about that. Also, if you click on time, there you get a whole bunch more of stuff that you could be working with. Over time, I am going to cover all of those, but for now, I think they're a bit too advanced. So this would be the first concept I want to cover. The second one is sometimes you want to have input for your shader, meaning you probably are going to have later on some code inside of this intro node. And from that, you want to control the shader. How could you do that? And well, for that, we get other kinds of nodes. Those are called parameters. If I simply type in parameter, we are getting a color parameter, a Boolean parameter, float, int, and we get a whole bunch more. Vector 2, vector 3, and vector 4 are also quite important. I suppose for now, to keep it simple, I want to create a float parameter. Double click on that, and now we are getting a float parameter where we can specify a name. Let's call this one the alpha value. And that value I want to connect to the alpha value in the output. If you have the sprite 2D selected and go to material, you should now see a shader parameters tab. If you click on that, you can set the alpha value. And this, if I set it to 1, is going to set all of the alpha values to 1, meaning we don't get any more transparency. We could also set this to 0.5 to get 50% and so on. Now, when you have these kind of parameter nodes, there are a few more things that you could be doing. For example, you could set a qualifier, but that's a bit more advanced. What is more interesting is the hint, because in there you can set a range or a range plus step. If I set this to range, we get a min and a maximum value. Once we have that, we are also getting a slider in the inspector, where you can simply move things up and down. We can also set a default value. For this one, I want to have 0.5. But other than that, that's basically all you need to get started. Now we can customize our shader a bit more, and let me clean this one up. That I think looks slightly better. I suppose what we could be doing to combine all of this is whatever kind of float input we are getting for the transparency. We want to divide it by 2. For that, I want to keep the float constant, and then the multiply node, the one that we have already created, is going to get the value of the alpha parameter. And this value we are passing into the output alpha value. With that, if I set the inspector value to 1, we are at the most getting 50% transparency. And with that, we have a pretty nice shader to get started. Next up, I want to rename this sprite 2D to, let's call it intro visual. That is important because next up, I want to create another sprite 2D, which also is going to get the icon as the texture. And let me zoom out so I can place them right next to each other. This sprite 2D is also going to get a shader. However, the shader we are going to give it is not going to be a visual shader. It is going to be a code-based shader. To make sure we keep those two apart, I want to name the sprite an intro code. With the new node selected, I once again want to go to material, assign a new shader material, click on the sphere, click on shader, and click on new shader. Now, on this dialog, we want to select shader and then give it a name. I call this one intro code. Also, for the mode, you want to have canvas item. Now I can click on create and nothing happens. To see the actual code, we want to click on the file again. And now we are getting another entry. And the visual shader is still in the file system. Now, to give me a bit more space, let me maximize all of this. We can see some shader code. There are some parts that are absolutely vital. The line at the top, you always need to have. This will define what kind of shader you have. In our case, we want to have a canvas item. After that, we have a function for a vertex shader and for a fragment shader. There's also a commented out light shader, but this one I'm going to ignore, so let me delete it. Also, for now, I only want to create a fragment shader, so the vertex shader we can safely delete. Alrighty, so with that, we can work inside of a fragment shader, and I want to do the same thing I have done inside of the visual shader. The way that is going to work is via a couple of custom keywords. For example, what we want to update for the shader is the color. This color is a vector 4. And to assign it this vector, we want to type vec4 to create a vector 4. In there, you can now see all of the options we have to pass into it. We could, for example, simply pass in a single float, and then we are going to need a semicolon at the end. Otherwise, Godot is going to complain. And now we are getting a color and a transparency. What you really have to understand is that this color is a vector 4, where we are getting red, green, blue, and the alpha value all in one. For all practical purposes, this color is basically from the visual shaders, color and alpha combined. Especially when you're getting started, this can be slightly confusing. But to make this a bit easier, what you can do is get color.a and then assign this to a value like 0.5. And now you are only specifying the alpha value. Alternatively, you can also get color.rgb and then assign a vector 3 to it. 0.9 for red, 0.1 and 0.1 for green and blue. And don't forget the semicolon. And now we're getting a reddish color. But other than that, if you know basic GD script, none of this should look too complicated. The only important thing that you have to understand is that whatever we are assigning to color, or more specifically color.a or color.rgb, that is going to be what we are doing to every individual pixel. On top of that, you do want to be careful about the data type. For example, for the alpha value, we want to have a floating point value, whereas for the RGB value, we want to have a vector 3. Also, you always want to add a semicolon after every single line. Can be a bit annoying, but it's honestly not too bad once you get used to it. Next up, what you can also do inside of the script is declare variables. Those variables can either be global to the entire script or local inside of a function. Let's create a global one, which you do with, first of all, the data type. For example, you have float or you have a vector 3 and so on. I want to create a floating point value that we have to give a name. Let's call it the amount of red that we have. After that, you want to assign it a value 0.5 and now a semicolon once again. Now we are getting an error that global non-constant variables are not supported. To fix that, we have to add a const in the beginning, and now Godot is going to stop complaining. On top of that, we have a variable. This variable we can use like any variable in any coding language you have ever seen. We can assign the red amount to it, and if I now press enter, we're getting a lower amount of red. So that's about it when it comes to variables. Although what you can do, if I undo the distraction-free mode, if you want to have, like in the visual script, a float parameter, the way you would get that is also via a variable. The only change you have to make is instead of const, you want to have a uniform. Once you assign that and you look at the inspector under shader parameters, we now have a red parameter. That is going to get a default value, which at the moment is 0.5, the value we have specified. On top of that, if you want to set a specific range, like we have done for the visual shader, you would have to add, after the variable name, a double colon and then the type hint. If you want to get a range for a floating point value, you would add hint range. Then you can set the start value, the end value, and the step size. If you don't want to have a step size, you simply get rid of the last value. After that, inside of the inspector, you can once again set a specific value inside of this range. Alright, and at this point, I have put on an overlay with the visual shader we have created earlier. This shader I now want to duplicate, except that now we are going to use code for it. For that, first of all, let me get rid of everything else so we have no distractions. I am going to start by creating 3 variables. One for the color constant, one for the float parameter, and one for the float constant. The color and the multiplier float constant are both going to be constants. So those are going to be constants. For the color, we want to have a vector 4. For the name, let's go with color. And we could assign this a vector 4, for example. Let's go with 0.8, 0.4, 0.3, and 0.5. The specific values really do not matter. Next up, I want to create a constant float. Let's call it the alpha multiplier. The value for this one is going to be 0.5. Finally, we will need the actual input for the alpha value, the one we are going to get via the parameter, so this one. For that, I want to create a uniform node that is going to be a float, and this one we can call alpha. For that, I want to have a hint range from 0 to 1 without a step size. And the default value should be 0.5. With that, we are getting all of the inputs. Next up, we want to assign, let's start with the alpha value. I want to get color and then assign the alpha value, which is simply going to be the alpha value we are getting from the user multiplied with the alpha multiplier. And once again, do not forget the semicolon. After that, we are getting 50% transparency right now. And if we update the alpha value in the inspector, we are getting different kinds of alpha values. That looks really good. After that, we want to work on the actual color, for which we can use color.rgb. And the value we want to assign to this is going to be a vector 3. And remember, in the original, we had a color, and then we decomposed this vector 4, but we only really looked at the red value. This red value we passed into x, y, and z of the vector 3, we then passed into the color output. Which means, for this vector 3, I want to get the color input, and then .r. After that, color.r again, and once again, color.r. And at the end, once again, don't forget the semicolon. And then we are getting the same output. Although this system is a bit overkill. If you create a vector 3 with a single argument, then this value will become the value for every single number inside of the vector. So we're getting the same output. And well, with that, we have translated a visual shader into a code-based shader. I hope that wasn't too difficult, and I think if you can write even a bit of GD script, this kind of code shouldn't look too unfamiliar. It really isn't that different. And that would be an introduction to fragment shaders. Next up, we can work inside of the visual shader again, because I also want to look at vertex shaders, at least briefly. The only value that we are going to work in there for now is going to be the vertex part. And if you look at this one a bit more closely, the color for this is, a different shade of pink. This means we are expecting a vector 2 that is going to have an x and a y value. The way that is going to work is that every single pixel inside of the graphic is going to get an x and a y value, which in turn is then going to determine where we are drawing this particular pixel. For example, by default, we might have a value here. So this would be the position of 1 pixel. But via the vertex shader, we can tell Godot to move this position a bit further to the right. And then we would basically draw the entire graphic or all of the pixels inside of the graphics further to the right. Let's actually do that. For that, we have to create a vector 2. So I want to compose a vector 2 via a vector compose node, which we are also going to connect to the vertex. And if I do that, we cannot see anything anymore. That is because now we are positioning every single pixel inside of the graphic to position 0 and 0. So we might somewhere in the game find 1 pixel with all of the colors of this graphic, but in practice that's not really useful. Basically what we want to do is we want to get the current values and then add something to it. Now to get the current value, we are going to need another node, which is called the vertex. If I get this and assign it to the output, we are getting the value of the current graphic and then assign that value to the current graphic again. We are basically assigning a value to itself. But what we can do instead is we can decompose this vector 2. For that, I want to have a vector 2 decompose and then connect it to our vertex input. This decomposed vector I now want to connect to the vector 2 compose and then assign it to the vector. And once again, we have basically assigned a value to itself. However, what we are now able to do, and for that I want to add a bit more space. When we are transferring the x value from the vector decompose to the vector compose, we can mess with it. For example, we can add another node. We simply want to add a value to a float. To this, I want to add the vector decompose, and then the output is going to be our x value. And right now, we're getting the x value of the original vertex point, and then adding 0 to it, which is not going to do anything. However, if I change this value to a 1, then we have moved the intro visual sprite 2D 1 pixel further to the right. Let me change this to 100, and now we can see we are moving the entire graphic further and further right. Okay, 5000 is a bit too much, let's say 300. This number could also be negative, let's say negative 200, and now it's further to the left. Furthermore, what we can do is add the time node and add this to the x position. And that way, we are continuously moving to the right, although very, very slowly. To make that work a little bit faster is multiply the time with a value. So I want to have the multiply float node and then add the time in there and then multiply it with some value, let's say 10. And if I now connect this node to this node and zoom out quite a bit, somewhere to the right, we can see the node moving further and further to the right. So this one is definitely working, but very difficult to see. Although if I run the entire scene again, now I can see this a bit better. We have this graphic moving to the right, even though we have written no code for the scene. We only have a shader. And what is really important to understand at this point is that we don't really move the sprite anywhere. We are simply drawing it in a different position. The bounding box of this rectangle is still in the original point. This one hasn't moved whatsoever. The only change that we have made is that we are drawing all of the pixels a bit further to the right the longer the game goes. And that is an introduction to a vertex shader. Honestly, it's not too bad, and there's nothing too complex that we have done in here. So next up, let's create the very same shader with some code. For that, we want to recreate the function I deleted earlier. We want to have void and then a vertex function. And by the way, if you are going to create a function, which you can do just fine, you want to start by defining the return value, then the name of the function, then the arguments, and then you want to have curly brackets. Inside of there, you can write whatever code you want. You don't have to indent it, but it's a bit more readable. We want to work with the vertex. More specifically, we only want to work with the x part of our vertex. This value we want to keep and update, so plus equal some kind of value, which in our case would be time multiplied with, I think I did 10 in the original. And now we get a really important error, that we have invalid arguments for the operator multiplication. We have a float and an integer, which is something really important to understand inside of visual shaders. When you're using GDScript, you can multiply a float and an integer just fine. When you're working with a shader, this is not possible. Time is a floating point value and 10 is an integer. As far as the shader is concerned, those are two entirely separate values that can never be combined. Although in practice, to combine them, all you have to do is add a .0 and then you get the right outcome. Meaning now, if I run the entire scene, we should see both nodes moving further to the right. And that looks pretty good. Now, what I also want to mention, this line of code is much simpler than the visual shader. If you wanted to translate this one-to-one, what you would have to do is assign a vector 2 to this vertex. Then we want to specify an x and a y value. For y, we don't really want to make any change. So this one could be vertex.y, and then we get the same value that we have already. For x, I want to get vertex.x plus time times 10. And now we are getting the same error that we are multiplying a float with an integer, so this should be 10.0. And now we are getting the very same result. Although to achieve it, we are writing a lot more code. And I think that's something you generally want to learn about shaders. When you are writing code, usually, if you're elegant about it, you are going to write significantly less logic than if you would use a visual shader. If I get back the thing I've done in the original, we simply got vertex.x plus equal time times 10.0. All of this does exactly the same as all of this. And I think you can see that writing these couple of words is much less work. And I think also easier to read. Started, but once you are more comfortable with shaders, they are just not as efficient. Although you should be able to read visual shaders in general, could always be handy. But anyway, with that, we have covered the fundamentals of shaders. So let's do an exercise and then we are done with this video. What I want you guys to do is create a completely new sprite 2D with the Godot logo. After that, use a shader 2. Move this node up and right. The speed for it should be set via the inspector. Via the inspector, you should also be able to specify the amount of red, green, and blue for the pixel color of this graphic. On top of that, the green value will always be divided by 10 and also set the transparency. Also make sure that you are creating both a visual and a regular shader to solve all of this. Pause the video now and see how far you get. Alrighty, here we are back in Godot, and first of all, I want to keep things clean, meaning I want to add another node 2D and rename it to exercise. After that, we can add 2 more sprite 2Ds. Let's put it like so. The first one is going to be the exercise code, and the second one will be the exercise visual. Both of those should be children of the exercise node. Now we can start with either one of those. The order does not matter. I suppose we could start with the visual one. Once again, I want to go to Material, create a new shader material, click on the sphere, click on Shader, New Shader, and create a visual shader. I suppose this one could be Intro Exercise Visual. That's all we need. If I now click on the shader, we can see once again our visual shader. And I suppose let's start with the fragment one. Since I want to have a floating point parameter for red, green, and blue, we need to start by creating float parameters. The first one we can call red, and for the hint, I want to have a range from 0 to 1. I suppose we can also set a default value of, let's go with 1. After that, I want to copy the node and create another one that's going to be green. And after that, I want to paste in another instance, which is going to be blue. All 3 of those, that way, are going to get a range and a default value. And while we're working in this, I want to full screen it, so it's a bit easier to see what's going on. Just to keep things organized, let me move them so they align. Perfect. With that, we have parameter inputs for all of the colors. These numbers I have to combine, which I'm going to do via vector recompose. I simply want to get all 3 values and with them create an XYZ vector, which is then going to be our color. And let's arrange this something like that. Now, if I look at the scene, we can see we have a white color. And that is because for red, green, and blue, we always have a default value of 1. However, if I go to shader parameters and reduce the amount of red, we're getting a bluish color, because now we only have green and blue. If I have no blue either, we are only getting green, so that is working pretty well. However, I do not want to have the full amount of green. I always want to divide that value by 10, which we can get by adding another value. I want to multiply the green color. So the node value from the slot we are passing in there, and then you can either multiply it with 0.1, or if you click on multiply, there's also divide, and you can divide it by 10. You would get the same result. The output of that value, we want to now pass into the vector. And let me organize this a bit better. That feels cleaner like this. And now we can see a pinkish color. That is because we keep the full amount of red and blue, but we only have 10% of the green color. If I remove that one entirely, not much is happening. But if I don't have any red, or any blue and the full amount of green, we have a very, very dark green color. So this one looks alright, but let me set the default values. Next up, the other part for the fragment shader was that we want to use the green color as the alpha value, which we can do by simply connecting the green color to the alpha value, and then we are done. If I now reduce the amount of green, we are also updating the transparency. Cool, and this thing is getting a bit messy, and well, that can just be a part of a visual shader. Sometimes you end up with lots of different nodes, and organizing this can be difficult at times. What you can try to do, if you click on this symbol with the arrows, then Godot is trying to align them, but that doesn't always work. Instead, you want to make sure that you have a ton of space, and I guess that looks a bit better. Not ideal, but I guess somewhat readable. Anyway, next up, I want to create the vertex shader. And for that, I want to zoom in and maximize this thing. Remember, we want to move this thing to the right and up. For that, first of all, we will need a couple of inputs. We need the vertex, we are going to need the time, and finally, we will need another node with the float parameter for speed. I suppose for that, we can set a range from 0 to 10 and have a default value of 5. The specific numbers here are entirely irrelevant. I just want to have something. Cool. With that, we have all the inputs that we need. We just have to figure out how to use them. And first of all, I want to vector to decompose the vertex position. So paste it in there. And now we have x and y. To each of those values, I want to add the time multiplied by the speed. For which, first of all, I have to multiply these two values, which I'm doing with a multiply node. I just get the values from both of them, and now I want to combine these two values, for which I can use an add float node. For A, I want to have vertex.x, and for B, I want to have the outcome of the multiplication. After that, I can copy this node, because next up, I want to get vertex.y and add to it the product of speed and time. With that, we have added both values, so the last thing that we have to do is to create a vector from these values, which is just going to be another node. And now we should be done. Let's try to run all of this, and we have a ping sprite that is moving. The problem is it's moving in the wrong direction. I want this thing to move up and right. That, fortunately, isn't that difficult to fix. At the moment, we are moving down because for vector.y, we are adding this value. But we want to do the opposite. We want to subtract the value, which we can do by simply changing this add to a subtract. And then I can run all of this again. And now this thing is moving up and right. That's perfect. And with that, I just want to organize this thing just a bit better so it looks cleaner. I suppose something like this feels better. It does get a little bit difficult to read, but at the moment, it's still fairly manageable. Anyway, with that, we have covered the visual shader. Next up, we can do the exact same thing, but using code. With the exercise code node selected, I want to go to Material, create a new shader material, click on the sphere, click on the shader, new shader. I want to create a normal shader. This one I'm going to call intro exercise code. And finally, we have some shader code. As always, we are not going to need the light, so this I'm just going to delete. After that, we are going to need a whole bunch of inputs, and let's do all of them in one go. I want to have a uniform float for the speed, for which we can have a hint range from 0 to 10.0, the default value being 5.0. After that, I want to copy the line, because next up, I want to have a red color. The hint range for that is from 0 to 1, with a default value of 1.0. Then I can duplicate this line 2 more times. That way, we are getting the green color, and we are getting the blue color. The hint range and the default value can stay the same. Next up then, I want to create the fragment shader, for which I want to update color.a. The value for this one is going to be the green color, and that's literally it. If I now look at the shader parameters, we have the green color, and this one is going to give us the alpha value. So that looks good. Next up, I want to update color.rgb. The value for this one is going to be a vector 3 with red, green, and blue. However, the green color we want to divide by 10.0. Nearly done. We have to add a semicolon, but after that, we should be good to go. And now we once again can update the colors, with the green color having very little influence, but it does change the transparency. Cool, that looks good. Although at this point, we are writing 2 lines of code, but we only really need one, because this line is ultimately really simple. Meaning, instead of doing these 2 lines, I want to comment them out and simply update the color as a vector 4. For that, we will need red, green divided by 10.0. Then we want to have the blue color. And finally, for the alpha value, we want to have the green color again. The end result of all of that is going to be exactly the same. We can still update the color, and green will also change the alpha value. After that, I want to work with the vertex shader. For that one, we want to update the vertices. And we want to get the current value and add a vector 2 to it, for which we are going to need x and y, and a semicolon. Now, for x, we want to get time multiplied by the speed that we are getting from the inputs, this one. For y, we basically want to do the same. So let me copy it. The only difference is that this would move us down, meaning if I run the code, at the moment we are working with this dark pink sprite, and it's moving and we have the color, but it's once again moving in the wrong direction. Which is happening because this value increases, but to go up we have to decrease the value, which we can do by simply adding a minus to one of the 2 variables. After that, we are moving to the right and we're moving up, so that looks pretty good. Also, just to test this, if I increase the speed to, let's say, 10 and run all of this again, now this sprite is moving quite a bit faster than the other sprite. So I think that's working just fine. Alrighty, and with that, we have created a whole bunch of shaders. I hope that was helpful. And in the future, I am going to create quite a few more shaders. So I hope I see you there. We're going to go into a lot more detail.